Hi boys and girls, here's lesson 5.4, which is all about adding mixed numbers. Please write this in your notebook as well as today's date, and then when you're done with that, come on back. So the math message for this lesson is this. I want you to solve this problem. Now you might want to use fraction circles or a number line poster to help you, but what I'm looking for is 2 1/4 is equal to how many fourths? Think about that. Think about those whole numbers in the 2 and what those would be in fourths. Okay? Try that problem. When you have some things written down, come back and check out the next slide. So here's some strategies you might have tried. So notice here, if the red circle is the whole, we could show 2 1/4 like this. Then we can replace each red circle with 4 yellow pieces because you know 4/4 is equal to 1. And then I can just count the fourths. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 2 1/4 is equal to 9/4. I definitely can use my fraction circles for this strategy. Another one, if I want to use a number line poster and count the fourths, I could do it this way. So first I'm going to decompose the mixed number 2 1/4 into the sum of 2 plus 1/4. And I can take it even further to say that the 2 becomes 1 plus 1 plus a fourth. I'm going to rewrite that whole number 1 as 4/4 to get an equivalent fraction with the denominator of 4. Because I have 1/4 here, that's why I know I want to go to fourths. So then I can tell myself, so 4/4 plus 4/4 plus 1/4 is equal to 9/4. Or rewrite the whole number as 8/4, because that's what 2 is. 2 is the same as 8/4. And do 8/4 plus 1/4 equals 9/4. I can show that up here by doing up to the 4/4 for 1, then up to the 8/4 for 2, adding one more fourth, which takes me to 9/4. So those are two different strategies. You may have yet another one we'll talk about during the lesson, but those are two really good ones for how to solve that problem. So let's try another number story with mixed numbers. Keep in mind those strategies I just talked about with the math message and see if they'll help you with this problem. So here it is. The cafeteria had 2 3/5 tubs of grape jelly and 1 1/5 tubs of strawberry jelly set aside for breakfast. How many tubs of jelly were there in all? So, of course, I hope you immediately think about the in all section of this statement and know that, oh, so I'm looking for a sum, right? In all, what's the total? I know the parts, what's the total? Therefore, I know I'm doing an addition problem. I hope you have that. So go forward with that knowledge to try and work with how you're going to break down these mixed numbers in order to be able to tell me the answer to the whole problem. After you've given that a try, come back and check the next slide. So here are some strategies you might have used. If I did the fraction circle model, the mixed numbers are going to be added. So the red circle could be used again to represent the whole. So here's my 2 3/5, 3 out of 5 pieces, 3/5. And here's my 1 1/5. I can combine like pieces, the reds, 1, 2, 3, and I can combine the like pieces, the fifths. I've got 1, 2, 3, 4, 1, 2, 3, 4. Therefore, I'm going to say my answer is 3 4/5. So I could definitely do it that way using the fraction circles. I could combine whole numbers and fractions by decomposing the mixed numbers into sums of whole numbers and fractions. So that's what you see here. I can combine the whole numbers to get 2 plus 1 is 3, and 3/5 plus 1/5. I know how to add those because they have common denominators. So that gives me 4/5 put it together, 3 4/5. Okay? Notice here they are telling you, you can also think about these as the labels, using the fraction part and the wholes as labels or as units, like we had talked about in class during lesson 5.3. So think about that. And then another way to solve it is to decompose each mixed number into the sum of a whole number and a fraction. So there we go. So take a look at what we're doing there. So I'm taking my 2 to 10/5 because I know 1 is 5/5. 2 would be 10/5. So if I do this, I'm going to end up with 19/5. And then I can take that back to a mixed number and say 5 goes into 19 3 times, and I'd have 4/5 left over. So when I think about this one, I want to ask, does it matter whether I combine the whole numbers first or the fractions first in this kind of method? I hope you would know it wouldn't matter. The turnaround rule for addition, or that's the commutative property, says that changing the order of the numbers being added doesn't change the sum. So I could do these either way. All right? So here's another problem for you. I want you to use the strategy that makes the most sense to you to try and solve this. So Scotty works at the deli counter at Bush's. That part is actually true. He does. He sliced 1 3/8 pounds of ham and then stopped to help a customer. When he was done with that customer, he sliced another 2 7/8 pounds of ham. How many pounds of ham did he slice in all? So again, it's an in all type of question, so I know what kind of math I'm doing. I'm not looking for the difference, which would be subtraction. I'm looking for in all. I want the sum, the total. So I'm going to be adding. Hope you got that. Go ahead and solve that when you think you have it. Come on back to check it out. And here we go. So I could draw a picture in order to solve this. Here's the amount that he did before the customer. I turned the 1 whole into eighths because I know I want to be in eighths because it's 1 3/8. So that puts me all at eighths. And then after the customer, there's the 2 broken into eighths and the 7/8. I'm going to combine these and put all of my whole ones together and then my partial ones together. And that's what I'm going to end up with. So I could definitely do it like that. You're going to see that I have 1, 2, 3, 4, and 2 eighths when I combine them. I can combine the whole numbers and fractions. I can decompose the mixed numbers into sums of whole numbers and sums of fractions. 1 3/8 plus 2 plus 7/8. I can combine then the 1 and the 2 to get 3, and the 3/8 and 7/8 to get 10/8. I can't leave this as 3 10/8 because in a mixed number we wouldn't leave an improper fraction. Improper fraction is when the numerator, the top number, is bigger than the denominator, the bottom number. So I'd need to convert that 10/8 into 1 2/8. So let me just make sure that you get that part of this. 10/8. If that's the fraction that I have, that's an improper fraction, it's called, which you're okay if I'm not in a mixed number. I can have improper fractions, but I can turn that into a mixed number by saying how many of these eighths will go in 10. Well, I know there's going to be 1 8 that will go into 10. What would be left over if I do 10 minus 8? I'm going to have 2 of those eighths left over because I know this. 10 is the same as 8 plus 2, right? You know that as well. So that's how that problem is working out. The 8/8 section here becomes the 1 whole, and the 2/8 is what's left. So keep that in mind. That's how you would solve that. That's what this section is doing for you right here. Or I could use the fraction names as units again. 1 whole and 3/8 plus 2 wholes. Those are the same, they combine. These are the same, they combine. Gives me this. All right. I could replace each of the